Let's get in depth about where Rippler gets its voice. The exciters, resonator banks, and oscillators, which all lead into the filters. Remember, each of these settings is replicated in an additional layer. We'll just stick with a single layer in this video. The exciter module and noise module are where the physical modelling starts. Just like an acoustic instrument gets plucked, struck, or scraped, these modules produce the initial sound, ready for the resonators to change it. You wouldn't usually use an exciter alone. In Rippler, they get sent through the resonators to add life and body to the sound you're building. The exciter has two modes to do its thing. The first mode, impulse, generates a short burst of energy. In this mode, you get a control for frequency and a noise multiplier. The second mode works using samples, helping you cover everything from percussion one-shots and piano stabs to Foley recordings, metal clicks, and vocals. When in sample mode, the exciter's noise multiplier changes to a low-pass filter for more control over the tone of the impulse. The exciter has a direct out control and a resonator output slider. You'll find the same on the noise module below it. In both cases, the resonator output slider determines how much of the signal is sent to the resonators for that layer, and the direct out control determines how much of the module's signal is sent straight to Rippler's effects section, avoiding the resonators. The exciter comes alive by allowing you to load your own audio files, up to 3 seconds long. Drop in anything from a pluck sample to an abstract field recording, and let the resonators react to the sonics of your own sample library. Let's take things a step further. Aside from loading in your own files, Rippler also supports the use of an audio input as your exciter source in most major DAWs. Sidechain your audio to Rippler in your DAW, and you won't hear anything immediately. Instead, you'll have to let the audio through by playing MIDI notes, which gate the audio to play through the resonators. One thing to remember about the resonators is that they work polyphonically. When you play a MIDI note, a resonator, or usually a pair of resonators, is created for the signal to run through. If you play a second note, a second resonator or a second pair of resonators are created. By default, and in almost all Rippler patches, the resonator's pitch is key-tracked to the note you play, so playing multiple MIDI notes will create multiple resonators tuned to different pitches. Sitting just under the exciter is a dedicated noise generator, which can feed into the resonators, be used as a separate layer, or both. With the built-in filter, the noise can have its tonality changed to be more like pink noise or other noise types. Just like with the exciter, the direct out knob routes the signal straight to the effects section. And you can raise the resonator output slider to send the noise into the resonators instead. Now we know where our sounds start, let's get into the core engine. Rippler ships with 13 resonator models to choose from: string, beam, squared, bell, membrane, plate, drumhead, djembe, vibraphone, marimba, open tube, closed tube, and a custom manual mode. The lines you see on each resonator represent partials. In their default state, partials are practically harmonics. The first partial is the fundamental frequency, the second partial is the first harmonic, and so on. But partials can alter and change in frequency so that they're not harmonically related at all. We'll go through this a little later. The decay and release parameters control the length of each note. The decay represents the time it takes for the resonators to fade out, and the release applies an additional damping factor when a note is released. The tone control works similarly to a filter, using a 12 dB roll-off, attenuating higher partials when boosted or lower partials when cut. You can change the construction properties of the acoustic instrument using the material control. It works similarly to the tone in its effect, but achieves this more by altering the properties of the virtual acoustic system. Higher partials can die off quicker when the material value is set lower, and lower partials die off quicker if the material value is set higher. If you've ever played a string instrument, you probably know that the sound changes depending where on the string you pluck or scrape it. This is replicated in Rippler using the hit control. You can see the complex change in the resonator's partials compared to where it's being struck. The inharmonicity control acts to stretch or contract the partials away from their harmonic ideals. Turn Inharm up and all the partials get sharper, even sharper the higher they are. Turn Inharm down and all the partials get flatter. This is most normal to find in acoustic string instruments, but this control can be applied to all resonator types. Some resonators, such as the plate, include a ratio control that modifies the tuning formula of the model directly. It's a quick way to emulate the change in dimensions of a flat 2D surface like a membrane, drumhead, or beam. If you find a resonator setup that you like, you can copy and paste resonators or even export them and save your setup for later. Once you've experimented with the built-in models, jump into manual mode to explore a fully interactive partial editor with up to 64 partials per resonator. Inside the editor, you can switch between two morphable snapshots, P1 and P2, that can be blended using the ratio control to create evolving timbres. Resonators can be routed in parallel or series. In parallel mode, the initial signal goes to both resonators at the same time, blending their outputs side by side. In serial mode, resonator 1 receives the initial input and feeds the output into the second resonator before going to the effects. But this isn't your usual serial chain. There's a bidirectional energy transfer between the two resonators. They actually influence each other's frequency response, feeding back into one another to create a truly unique effect. The higher you push the strength, the more dramatic the interaction between the resonators becomes. This feature is one of the most powerful parts of Rippler, allowing you to create entirely new instruments that don't exist anywhere else. Each layer also includes 2 oscillators, offering classic basic shapes as well as more white and pink noise. These layer into the synth sound after the exciters and resonators, so can be thought of as sub-oscillators, but they don't have to be tuned low. The oscillators bypass the resonators and go straight to the filters, making them useful for layering a more conventional synth tone along your acoustic modelled sounds. Each oscillator has dedicated fold and asymmetry controls for wave folding and asymmetric distortion, letting you add a thick harmonic bite to layer in with the sound and send to the effects. If you want to take your oscillator's tone a step further, click under the fold or asymmetry controls to unlock additional wave shaping models, including tube, soft clip, and hard clip. Additionally, the wave shaping controls can also be swapped out for phase controls, allowing for pulse, quantize, bias, bend, skew, sync, and sync window controls to get full customization of your oscillator's tone. Rippler ships with a wide net of filter architectures to choose from, each with its own distinct character. Starting with the classics, the standard filters cover low pass, high pass, band pass, and notch shapes at 12, 24, or 48 dB slopes. For something more textural, the comb filters can help you dial in anything from subtle metallic coloration to full-on comb-filtered resonance. If you're after that classic analog low-end warmth, the ladder filters offer low and high pass modes, while the vintage filters add additional slope options with a different character. Finally, the vowel filter recreates formant vocal style resonances, letting you morph your sound through vowel shapes for an instant talking or singing quality. Alongside the bank of filter types, you've got classic filter controls. Frequency sets your cutoff frequency, and Q dials in resonance. Push it up for a classic resonant filter, or keep it gentle for a smoother sweep. On top of all that, use the drive control to add saturation, changing the filter's behavior depending on which type you've selected. Just like the resonators, the 2 filters can run in parallel or series. Each filter can take its input from the resonators, oscillators, the noise generator, or the exciter directly, allowing you to filter your whole layer all together or split things up and filter individual parts separately. Now we've covered where Rippler's sound is born and raised. Next, we'll get into bringing your patches to life using Rippler's deep modulation system.